Hey, I am going to talk at you guys for about 5 minutes or so about temperature. During the 5 minutes of me talking at you, I might ask you to hit pause, or you might want to hit pause to take some notes. I'm going to be checking to make sure that you took notes. You could do it after the video, and there's no way I would know. That seems like cheating, though. So just hit pause every once in a while, take some notes in your notebook. Temperature is the first topic in our unit on thermodynamics, which we'll do for the next 2 or 3 weeks or so. That starts in chapter 13 in the book, pages 354 to 356. You can take a look through those if you'd like also after watching this video and taking some notes. For right now, we're just going to call temperature how hot or how cold something is. Katy Perry would be proud of that definition. But temperature, how hot or cold something is. Later on, we'll come up with a more scientific type explanation, but for right now, I'm good with that. To start off, we need to take a look at the differences between Fahrenheit and Celsius, because taking a look at this map of countries using the metric system versus countries not using the metric system, us, USA, good old USA, as well as the thriving metropolises of Liberia and Burma, are the only three countries in the world that do not use Celsius to measure temperature. We are being stubborn and using Fahrenheit. So because of that, we need to get comfortable with converting between Fahrenheit and Celsius in order to be like the rest of the world. 1 Fahrenheit degree is 5/9 of a Celsius degree. That means that a Celsius degree is a larger amount than a Fahrenheit degree. A change of 1 degree Celsius is a bigger change in temperature than a change of 1 degree Fahrenheit. Also, freezing temperature of water is 0 degrees Celsius, which corresponds to 32 degrees Fahrenheit. Using those two facts, we can write one equation that lets us convert from Fahrenheit to Celsius. So if you had a temperature of 32 degrees Fahrenheit, that would go right here where it says T in degrees Fahrenheit, temperature in degrees Fahrenheit. 32 degrees Fahrenheit minus 32 is 0, times 5/9 to account for the differences in scale. 32 minus 32 times 5/9 is 0. So that tells us that at a temperature of 32 degrees Fahrenheit, the temperature in Celsius is 0 degrees. That checks out. We're good to go with that. Doing some algebra-ing, we're able to also write an equation that allows us to go from degrees Celsius to degrees Fahrenheit. I just manipulated this equation to go from this one to that one. That one says that the temperature in degrees Fahrenheit is 9/5 to account for the differences in scale, times the quantity temperature in degrees Celsius plus 32 to account for the differences in freezing temperature. If you want to do some mental conversion, which we're able to do some estimates, if you're doing like quick calculations on an AP exam, or you're driving near Canada and you want to know what they mean when they say that it's 2 degrees Celsius out, you need to remember that 0 degrees Celsius is 32 degrees Fahrenheit, and a change in 5 degrees Celsius is equal to a change in 9 degrees Fahrenheit. This is around a 1-to-2 ratio if you want to do quick AP calculations. A change in 1 degree Celsius is pretty equal to a change in 2 degrees Fahrenheit. For right now, why don't you guys just take a second to get these equations and these mental conversion factors written down. Hit pause, make sure you have this stuff copied down, and I will keep on keeping on. Another scale that we need to talk about is Kelvin. Kelvin uses the same scale as Celsius, but it's shifted, so 0 Kelvin. You never say degrees Kelvin, you just say blank number and then Kelvin. So 0 Kelvin is absolute 0 rather than the freezing point of water. Here's the equation that lets us convert from Celsius to Kelvin. If you had a temperature of like 2 degrees Celsius, that would correspond to 2 plus 273.15, so 275.15 Kelvin. To kind of see that using 3 thermometers side by side. Absolute zero is 0 Kelvin, negative 273.15 Celsius, and negative 459 Fahrenheit. And then the temperatures at which water freezes and water boils, those are also given on this chart. You can hit pause if you'd like to jot this stuff down or any stuff on the last page. A sample problem. The only sample problem that we'll do in this this little mini topic. Normal body temperature, 98.6 degrees Fahrenheit. What is this in the Celsius scale and what is this in the Kelvin scale? First off, I want us to all do a mental estimation using the fact that 0 degrees Celsius equals 32 degrees Fahrenheit. You can yell at me for not putting units in there if you want to. And a change in 5 degrees Celsius is a change in 9 degrees Fahrenheit, so that's like a 1 to 2-ish ratio. I want us to do a mental estimation of this. And then afterwards, show your work, check to see if you're right using the equations. I have the work that I'm going to put on the next page, but for right now, hit pause, do a mental estimation, see how close you are, then check it using the equations. So hit pause. You didn't hit pause yet. You're just waiting for me to show you the answer. Seriously, hit pause. Do it. Hit pause. Okay, I believe you now. To do a mental estimation, here's how I'm going to do this. 98.6 degrees Fahrenheit. First thing I'm going to do is I'm going to account for the differences in freezing temperatures. So the differences that the scale is shifted. So 98.6 degrees Fahrenheit, that's like 100 degrees Fahrenheit. 0 Celsius is 32 Fahrenheit. So 100 degrees Fahrenheit minus that 32, that's like 70-ish degrees Fahrenheit. And then there's a 1 to 2 ratio between Celsius and Fahrenheit. So that means that my 70-ish degrees Fahrenheit, divide that by 2. So this normal body temperature, I'm going to say is 70 divided by 2, which is 35 degrees Celsius. That's my guess for that. So my guess is 35 degrees Celsius. And then in the Kelvin scale, that's shifted by 273. That's like 270. So 35 plus like 270. I'm going to go with 35 plus 270. 305. Is that right? Did I do that math right? Plus 2. Yeah, 305 Kelvin. That's my estimation for that. On my next page, we can check work using the equations. So actually doing it, actually using the equation that lets us go from Fahrenheit to Celsius, we're going to plug in the initial degrees Fahrenheit, 98.6 degrees Fahrenheit, turn the crank of doing the math. We got 37 degrees Celsius for that. That is pretty close to our my mental estimation of 35 degrees Celsius. The next part, to convert from Celsius to Kelvin, we're going to use this equation. Plug in our 37 degrees Celsius, add that to 273.15 degrees Celsius. The temperature in Kelvin, normal body temperature in Kelvin, is 310.15, which again was pretty close to our mental estimation. We're done with the temperature. Quick video. Go back, read through the pages in the book, make sure you're okay with this. Video is only 5 or 6 minutes long, so go back. You can watch it again if you want. Maybe it'll make a little bit more sense a second time through. Hit pause if you want to. We'll talk about it more in class the next time. Goodbye.